All right, two more problems like I promised. So the next one, example 3, the optimal tilt for Keenan's solar panel is between 58 and 60 degrees to the horizontal. Has Keenan placed his solar panel at an optimal angle, right? So the angle we're looking for is this angle right here. That is the tilt of his solar panel made with the horizontal, which is this dotted segment. So we need to find this angle, right? So notice what we're given. We're given lowercase side p, we're given lowercase side r, and lowercase side q. We're given the side, side, side situation, which means we can use the law of cosines to find this angle. And again, as I mentioned, if you have to solve a triangle, find the largest angle first. But if you're just finding an angle, again, you have to use law of cosines. Just find that angle using law of cosines. You will get the exact angle you're looking for. My whole find the largest angle first is if you have a choice and you have to solve the triangle. Okay, so I hope I don't mean to confuse, right? It is a little confusing for me too as the teacher, but it is because of the way the inverse sine and inverse cosine behave. All right, so let's go ahead and find this angle P. So that means we have to use this formula. So P squared, again, side P because we're looking for angle P, equals, we're doing Q squared plus R squared minus 2QR cosine of P. So I know that lowercase p is 19, so 19 squared equals. I know that lowercase q is 18 squared plus an r is 20 squared minus 2 times 18 times 20 cosine of p. And again, here's the situation, right? Do 19 squared, do 18 plus 20 squared, and then do negative 2 times 18 times 20. So 19 squared, I should know it off the top of my head. It is 361. I didn't know it. I had to look. 18 squared and 20 squared, that's 324 and 400. I knew that. That's 724. 2 times 18 is 36, times 2 is 720, cosine of p. Again, don't be tempted to combine the 724 and negative 720. That's wrong. That's wrong, okay? And you'll get a, I don't think you'll get a right answer, all right? So just be aware of that. So now we're going to move the 724 to the left by subtracting it. So that gives you negative 363 equals negative 720 cosine of p. Then we're going to divide by negative 720. The negatives cancel, and your cosine of p equals 363 divided by 720. And now you're going to take the inverse cosine of that. So to find the measure of angle p, take the inverse cosine of 363 over 720. So again, I can type that in just as it looks, and I'm going to do that this time. Right? So I've taught you how to use the answer to drag it in. You can use the second minus key in your calculator, your graphing calculator, but we'll just type it in exactly as it looks. And we'll run round to the nearest tenth. Okay? And again, we're looking to see if we're in between 58 and 60. 363 divided by 720. So we're going to do inverse cosine. And let me double check to make sure I'm in degree mode, right? It's not always a bad thing. Degree is good. Inverse cosine of 363 divided by 720. Notice that the fraction is inside the parenthesis, like the 720 is not underneath the cosine, right? And there we go. I got an angle of 59.7. So the measure of angle P is 59.7 degrees. And because that is in between 58 and 60, his panel is at the optimal angle. So I'm going to say 59.7 degrees is between 58 and 60 degrees. So he is at the optimal angle. There we go. Or at an optical angle, right? Because you could be any angle. So 59.7 degrees is between 58 and 60, so he is at an optimal angle. Great. Okay, let's do one more. All right. Again, I think right triangles are applicable in this world a lot, but there are also non-right triangles, so it's great to have other methods to solve non-right triangles. Okay, so it says the district ranger wants to build a new ranger station at the location of the fire tower because it would be closer to Bald Mountain than the old stations. Is the district ranger correct? Explain. So here is the fire tower, right? He wants to put a new ranger station at this location here, right? So the question is the distance from this fire tower, I'll call it F, to Bald Mountain, call it B, is this distance, which we don't know, is it shorter than the current ranger station to Bald Mountain, which is 2.1? So if you notice here, right, if we call this R, that F, and that B, right, there's my triangle, RFB, right? So this 1.4 would be lowercase b, this 2.1 would be lowercase f. We don't know lowercase r, but notice we have side, angle, side. We have the SASK, so we can use the law of cosines to find this missing opposite side r. So we're going to do r squared equals, I'll call it b squared plus f squared minus 2bf cosine of r. So we don't know what r squared is, right? We know that b is 1.4, we're going to square it, plus f is 2.1, we're going to square it, minus 2 times 1.4 times 2.1 cosine, and r is 49 degrees. And again, remember, you're going to take the square root of that. So we can type in this whole right side all at once, and it'll give us the value of r, including the square root. And I'm looking to see if it's less than 2.1. Okay, so I am in degree mode. So square root of, so I'm going to do 1.4 squared plus 2.1 squared minus 2 times 1.4 times 2.1 cosine, and the angle is 49 degrees. And there I go. That new distance r is going to be 1.59. So because, or what would it say? Is he correct? Yes, he's correct. Because 1.59 is less than 2.1. And there you go. All right, perfect. Great job. So again, good luck on this section. If you have any questions, let me know. All right, and we'll see you in class.